Okay, so your sigma notation represents a summing of a series. Right? And whenever you use the sigma notation, you have to include the general term either of the arithmetic sequence or the general term of the geometric sequence. We don't have a quadratic series. Okay? For you guys, there's no quadratic series. So only you are going to encounter two types of series, arithmetic series or geometric series. Alright? And you should be someone who is familiar with finding the general term of an arithmetic sequence, the general term of a geometric sequence. If you know how to do that, then you should not have any challenges with the sigma notation. Now, when we write the sigma, when we write down the sigma notation, it's very important for you to be aware of this. You write the sigma notation, then you must indicate the position of the first term. So like here, it's k from k equal to 1. It means the first term is going to be determined by substituting k equal to 1 up to k equal to n. Okay? So n is going to be the position of the last term. The position of the first term is going to be equal to k equal to 1. So your first term will be T1, the last term will be Tn. Sometimes you can have, say, k starting from k equal to 2. It means you substitute 2 into that general term first, then you carry on. Alright, if you can't see, let me zoom this. Yes, this is k equal to 1, and then the top there, that's n. K equal to 1 represents the position of the first term, and that n on top there represents the position of the last term. Okay, and here where I wrote MAS, that's Mind Action Series. Remember, we have got two ebooks, the Mind Action Series and the Platinum Math. So I took these examples that I'm going to do from exercise 3 on page 3 of the Mind Action Series textbook. Can I carry on? Because I need to finish this. Okay, so let's do some examples. All right, let's start with question 1. It says expand and then calculate each of the following. Now, whenever you are given the sigma notation and you are asked to calculate the sum, first determine the first 3 terms of that series. Okay? Determine the first 3 terms of that series. Then use those 3 terms to determine either the common difference or the common ratio. So I'm going to rewrite this on the next page. So number 1, it is sigma from n equal to 1, says after it's r equal to 1. From r equal to 1 up to 5. Okay? of 3r minus 5. Now, this 3r minus 5 is a general term. Okay? 3r minus 5 is a general term. Please be aware of that. That's a general term. Okay? So if I want to carry on now, I have to substitute r equal to 1 into the general term. Okay? So I can write equals, since there are 5 terms, okay, I can add them manually after substituting r equal to 1, or I can use the formula. Okay? So I just need the first 3 terms. So if I substitute r equal to 1 here, 3 times 1 gives me what? 3. What is 3 minus 5? Negative 2. So the first term is going to be negative 2 plus. It's because of the sigma notation means we are talking about a series. Okay? The second term, I'll substitute r equal to 2, put 2 here. 3 times 2 gives you what? 6. 6 minus 5 gives you 1. So the second term is going to be a 1. The third term, I have to substitute r equal to 3. So I'll put r equal to 3 here. 3 times 3, that's 9, minus 5 will give me a 4. Then I can say plus plus. Up to the what? Up to the fifth term. Now, I don't need to find the fourth term and the fifth term. Okay, if you want, you can, but in my case, I don't want to do that. Okay? So, once I have these 3 terms, I need to determine if there's a common what? Difference. What is 1 minus 2? What is 1 minus 2? Sorry, 1 minus minus 2, it gives you what? A 3. 1 minus minus 2 gives you what? A 3. Okay? Then 4 minus 1 gives me what? A 3. Now, what this means is, this series here is arithmetic. Okay? It is what? Arithmetic. Alright? Now, I can use this formula, since it is arithmetic, Sn equal to n over 2 times 2a plus n minus 1 times d, to find the sum of those 5 terms. So I now know from here that my first term is negative 2. The number of terms is what? 5. This 5 here, that will be your, okay? Okay? If you are starting from r equal to 1 up to 5, means you've got 5 terms in the series, or 5 terms in the arithmetic sequence. Alright? So I have my A, my D, I just calculated is equal to what? To 3. Then I'll use my formula, Sn equal to n over 2 times 2a plus n minus 1 times d. Okay? Then this will be equal to 5 over 2 times 2 times minus 2 plus 5 minus 1 times d, which is a 3. And then you simplify that. So that will be S5. Okay? Now if you simplify this, this will give you 12. That will give you minus 4. So you end up getting 8. So 8 times 5 will give you what? 40. 40 over 2 will give you 20. So the sum of the first 5 terms is going to be a 20. Can you check that for me? This is a 4 times 3, that gives you 12. 12 plus minus 4 will give you 8. Right? 8 times 5 gives you 40. 40 over 2, that's 20. Now, I want you to be aware that the question here was saying expand. Okay? Expand. So I just determined the first 3 terms. If you want, you can go as far as the 5th term here. So if I substitute r equal to 4 here, okay, r equal to 4, I'll get 4 times 3 is 12. 12 minus 5 will give me what? 7. So I'm now having the 4th term as a 7. Then I don't need to continue substituting r equal to 5. You see these 3 here. To get the next term, I just have to add 3 to that 7. The next term will be what? 10. Once you know your common difference, then it is easy for you to write down all the terms. Especially if it's an arithmetic series, it's easier. Because you just add what? A D. And then you get all the consecutive terms. Right? What I have done here is called expansion. This part here. That's the expansion. Okay? This is called what? Expansion. The act of substituting the value in or the variable in the sigma notation to determine the consecutive terms, okay, in series form, then we call that the expansion. Usually, 3 terms are fine. They will give you an idea whether it's an arithmetic series or it's a geometric series. Any question? Now, okay with that? Let's choose the question with the geometric one. Right. Now, a geometric one, like this one here, it says from r equal to 0. Okay? From r equal to 0 up to 5. So I'm going to do that from D. Okay? So 1D sigma from r equal to 0 up to 5. Of what? Okay? The general term is 2. Actually, it's I. So it's not R, but it's I. This is I. Let me remove that R there. That's an I. Of 2 to the power of I minus 1. Yeah. Okay, can I ask you a question? I want to ask you, how many terms do we have in this series? If we are starting from I equal to 0 up to I equal to 5. 6. Okay, it's not 5, but it's 6. It means we are starting from 0 itself. So 0, 1, 2, 3, 4, 5. How many terms? 6 terms. If we start from I equal to 1 up to 5, then we have what? 5 terms. Okay? If we start saying from I equal to 2 up to 5, how many terms? 4 terms. And so on. Okay? So, I want to determine whether it's really geometric. So my next step is to substitute I equal to 0 here. I'll get 2 to the power of minus 1. Which is the same as the what? A half. You agree with me on that? Yeah. So I can write here a half, because we are in grade 12. If I substitute I equal to 1 here, 1 minus 1 gives me what? 0. 2 to the power of 0 is a 1 plus. If I substitute I equal to 2, I'm going to get 2 to the power of 1, which is a 2. Then I can write here plus up to the 5th term. Right? Now, if I want to find the common ratio, right, it will be T2 divided by half, I'll get what? 2. 2 divided by 1, I'll get 2. So here, my first term is a half, my common ratio is a 2, the number of terms, be careful now, the number of terms is not 5, it's what? 6, because we are starting from I equal to 0. Then we use this formula, Sn equal to A times r to the power of n minus 1 all over r minus 1. Okay, so if I use that formula, write it down, Sn equal to A times r to the power of n minus 1 over r minus 1. So this will be S6. My first term is a half. My common ratio is 2. The number of terms is 6. Alright? Then where there is r there, you put what? 2 minus 1. Right? I need to show you something with regard to a calculator. How to convert any number to a time base. Do you know that? Using your calculator. Huh? If you simplify here, 2 to the power of 6 is 64. Right? 64 minus 1 gives you 63. Then 63 times a half, that will give you 31.5 divided by 1. So you get S6 equal to 31 and a half. Okay, just check that for me.
It's right.
right? So the sum of those 6 terms is going to be 31 and a half. Any question? He's like, okay. Huh? Which minus? Yeah, it's from its context. It's from the formula, remember? It's from the formula. All right. Here's the question. I need to do an example now where you are given an expansion. You have to use the sigma notation to represent that 6. Okay? So let's move on to the next type of question. That's number 2. Write each of the following using the sigma notation. Do you have a question?
You say it is 1.5.
31.5. Yeah, it's fine. But generally, just avoid using decimal. Okay? Avoid using decimal. But if you write, if the answer is 31.5 is true for it. Okay? Okay, I need to do this example before I only have about 10 minutes. I need to show you how to do the Pythagoras what time to remember because I discussed it with the other class. So I need to show you. Okay. Allow me to you can catch up. I'll send you the PDF. Yesterday there was a mistake which took place somehow. All the way was PDF form, PDF format, but fortunately the video was made. So today I'm very careful. But let's start with 2A. The question says, write each of the following series in sigma notation. Okay? Now, I'm going to use n. Okay? I'm going to use n. So if I'm going to use n, it means if I get that series, that is 2 plus 4 plus 6 plus 8 plus 10 plus 12. How many terms are there? 6. There are 6 terms, right? So if I start from n equal to 1, I'll end at what? N equal to what? 6. So I need to determine whether it is geometric or it's arithmetic. Start with arithmetic first. 4 minus 2 gives you what? 2. 6 minus 4 gives you 2. 8 minus 6 gives 2. Since I've got a constant common difference, it means it's arithmetic. Okay? Then you need to remember that the general term of an arithmetic series is Tn equal to a plus n minus 1 times d. You need to find the general term of this, series. Okay? In terms of Tn. You need to find the general term. Remember, these terms here, they form a sequence. So we will need to determine the general term of that sequence. So, our first term is 2, d is 2, and n is 6. So if I substitute there, Tn equal to a plus n minus 1 times d, that will be Tn equal to a is a 2, okay, n, remember we are finding the general term, so we don't need to put the value of n there, right? D is also a what? A 2, okay? So this gives you Tn equal to 2 plus 2n minus 2. Then you get Tn equal to 2n. Alright? You following that?
Can I ask, as you're working with the series, so 23 is a
I want you to pay attention carefully. If you want to write a series using the sigma notation, you have to determine the general term of the sequence of those terms. Okay? So, here I had to determine the general term of the terms in the series. The terms form an arithmetic series, which means they are part of an arithmetic sequence. Hence, I can determine the what? The general term of that arithmetic sequence. Okay? And to determine the general term, we use the Tn formula. If you want, you can use the one that we were taught in grade 10 and last year. So I now have the general term, right? So I can write my answer as, I can write it here, therefore, let me write it down in the next page, okay? Write the next page. So it's 2. So I can say, therefore, 2 plus 4 plus 6 plus 8 plus 10 plus 12 is the same as sigma. We are starting from n equal to what? To 1. Sigma from n equal to 1 up to n equal to what? To 6. Well, there are 6 terms. Okay, what's the general term? The general term is 2n. So I'll put what? 2n there. Okay? The left-hand side is called the expansion. The right-hand side, that's the sigma notation of that series. Are you following?
Yes, sir.
So, if you want to understand the concept of the sigma notation, first you must know, or you must become a guru of finding general terms of an arithmetic sequence and of a geometric sequence. Yes? Alright, I need to show you something, so I'm going to stop here for today. Alright?